Of our five classically recognized senses, touch, hearing, vision, smell, and taste, only the last two are purely chemical in nature. That is, they can detect actual chemical molecules. Through our remarkable senses of smell and taste, we experience different olfactory and gustatory sensations from contact with the molecules of different chemical compounds. You'll be hearing the word molecule frequently throughout this book. Don't panic. All you need to know is that a molecule is, in the words of a first grader of my acquaintance, one of those eensy-weensy things that stuff is made of. That definition, plus the corollary that different stuff is different because it's made of different kinds of molecules, will stand you in good stead. The sense of smell can detect only gaseous molecules floating around in the air. The sense of taste can detect only molecules dissolved in water, whether in the food's own liquid or in saliva. You can't smell or taste a rock. As is the case with many other animal species, it is smell that attracts us to food, and taste that helps us find edible and appetizing foods. What we call flavor is a combination of odors that our nose detects and tastes that our taste buds detect, with additional contributions from temperature, pungency, the sting of spices, and texture, the structure and feel of the food in the mouth. The olfactory receptors in our noses can differentiate among thousands of different odors and contribute an estimated 80% of flavor. If this figure appears high, remember that the mouth and nose are connected, so that gaseous molecules released in the mouth by chewing can travel upward into the nasal cavity. Moreover, swallowing creates a partial vacuum in the nasal cavity and draws air up from the mouth into the nose. Compared with our sense of smell, our sense of taste is relatively dull. Our taste buds are distributed mostly over the tongue, but are also found on the hard palate, the front bony part of the roof of the mouth, and the soft palate, a flap of soft tissue ending in the uvula, that little thing hanging down just before the throat. Traditionally, it has been thought that there are only four primary tastes: sweet, sour, salty, and bitter, and that we have specialized taste buds for each. Today, it is generally agreed that there is at least one other primary taste, known by its Japanese name, umami. It is associated with MSG, monosodium glutamate, and other compounds of glutamic acid, one of the common amino acids that are the building blocks of proteins. Umami is a savory kind of taste associated with protein-rich foods such as meat and cheese. Moreover, it is no longer believed that each taste bud responds exclusively to a single kind of stimulus, but that it may also respond in lesser degrees to others. Thus, the standard map of the tongue in textbooks, illustrating sweet buds at the tip, salty buds on either side of the tip, sour buds along the sides, and bitter buds at the back, is an oversimplification. It shows only the areas where the tongue is most sensitive to the primary tastes. What we actually taste is the overall pattern of stimuli from all the taste receptors, the cells within the taste buds that actually detect the various tastes. The recent success in sequencing the human genome has enabled researchers to identify the probable genes that produce the receptors for bitterness and sweetness, but not yet for the others. When the combined taste, smell, and textural stimuli reach the brain, they remain to be interpreted. Whether the overall sensation will be pleasant, repulsive, or somewhere in between will depend on individual physiological differences, on previous experience, just like my mother used to make, and on cultural habituation. Haggis, anyone? One taste sensation is undeniably the favorite of our species and of many others in the animal kingdom, from hummingbirds to horses. Sweetness. To paraphrase a famously ungrammatical advertising slogan, nobody doesn't like sweetness. Nature undoubtedly set us up for that by making good foods such as ripe fruits taste sweet and poisonous ones, such as those that contain alkaloids, taste bitter. The alkaloid family of plant chemicals includes such bad actors as morphine, strychnine, and nicotine, not to mention caffeine. In our menus,